So most of the parts of this will be review, total review. But there's going to be parts that you're going to use what you've learned, and then there's going to be parts where we're going to have some like brand new things. So I want y'all zoned in, kind of locked in, ready to roll. So GCF, what is that?
Greatest common factor.
Yes. And then what is the difference between a factor and a multiple?
A factor has a variable.
Factor is something that you multiply
To
get-
create some,
Yeah.
yes. And then a multiple,
A multiple is something that is in all of them.
okay. What would be factors of 15?
5,
What would be a multiple of 15?
5, 30.
30.
30.
45.
All right. So it's what 30 makes up versus what makes up 30. Okay? And we're looking at what makes up 30. So,
Miss Scrubs was making us clean up all of the trash.
Yeah,
So
there's
how
so
much
much
there's
trash
We have
on
to clean
the
all of it up.
tables. We had to clean it all up
Well,
because everyone left it.
And then she had to have like a talk with
Yeah,
them.
she was yelling at us.
y'all are also being recorded. Because I had to start. Go ahead. So y'all pass those out amongst you. So, what would be the greatest common factor for the first one? 5. Now, let's look at what we would do this next one. We're going to do factor trees. So, if we have 18 and 36, what would be two factors of 18?
3.
You could do 6 and 3. You could do 9 and 2. I would not do 1 and 18 because it's not going to get you anywhere. You're still back to 18. So if we did 6 and 3, and then break down 6 to be 2 times 3, because we want it to be prime numbers. And then 36, what could you use?
6.
Okay, we could do 6 times 6, and then 6 is 2 times 3, and 6 is still 2 times 3. And then we're looking at what they share. So, do they share a 2?
Yes.
Yes. You write it down one time. Do they share a 3?
Yes.
Yes. And we write it down one time. And do they share another 3? Yes. And we write it down one time. So, 9 times 2?
18.
All right, so the numerical part, your coefficient, greatest common factor would be 18. So work with the numbers first and then work with your variables. So we found the numbers, and then our variables, we have an x and a y, and we have a y squared, which is the same as y times y. So do they share an x?
No.
No. Do they share a y?
Yes.
Yes. Do they share another y?
No.
No. So just the y. So 18y would be our final answer for number 2. All right. Having 3 numbers or 3 terms to work with has a different approach. You need for all 3 numbers to share the factor. So 15, 35, and 70. And again, we'll come back and look at the variables in a minute. So factors of 15
5 and 3.
and 35
6
6 and 5.
and no, not 6 and 5,
6 and 6. Or 5 and 7.
5 and 7, and 70. 10 and 7, and then for 10,
2 and 5.
2 and 5. All right, and then I'm bringing down that 7. So we have all my factors lined up so we don't leave anybody out. So do they share a 5?
Yes.
Yes. All 3 share a 5. Do they share a 3?
No.
No. All right, and then we come over here and we have where 7s are being shared. But all 3 do not share a 7. So we can't count our 7s. So our only number part, the coefficient part, is a 5. And then we look at our variables. We have an x squared, we have a y squared, and we have an xy. So we know x squared is like 2 x's, y squared is 2 y's. So do they all three share an x?
Yes.
No.
No. Do they all three share a y? No. So the only greatest common factor that those three terms have is 5. No variables. Do what?
Does it matter which numbers you pick? Like, usually when factoring out the numbers.
Like for 8, like in number 2, when we factored 18, we could have done 92, 6, and 3. You'll get the same base. Your prime factorization, you'll get there from the same way. All right. You do number 4, but don't announce the answer. So what did you get for your final answer for number 4? 2xy. Are y'all good with just finding the greatest common factor? All right. The next part, we're factoring completely. So, is there a question? Oh, you're catching her up?
Yes, ma'am.
Thank you. If we have 4a, and this is
Is this for number 5?
plus 3a. So if we were given this problem, 4a parenthesis 2 plus 3a, and we were told to distribute, to combine, what would we get for our final answer?
11A?
No.
Oh, wait, no.
8a
Plus 12A squared.
plus 12a squared. How did you get that? What operation did you use when you distributed? But what operation when you distributed?
Multiplication.
Multiplication. We multiplied 4a by each of the terms to end up with the final answer. Okay? Basically what we're doing down here is here's the final answer right here. We're going to figure out what it looked like before it was distributed. See, like 4a is actually the greatest common factor for 8a plus 12a squared. Okay? So, if we have 8 and 12, and we break those down into 4 and 2, and then 2, 2, 2, and then our 12, we said 3 and 4.
It's not.
So, do they share a 2?
Yes.
Yes. Do they share another 2?
Yes.
Yes. Do they share another 2? Nope. And then, of course, they can't share the 3. So 4 would be the greatest common factor for the coefficient. So I'm going to erase that and write that down. And then looking at our variables, we have an a and an a squared. Do they share an a?
Yes.
But do they share the second a? No. So do you see how we ended up with a squared as the greatest common factor here?
Yes.
Now, what we're going to do is take 8a and divide it by the greatest common factor. Remember, when you are dividing monomials, you subtract your exponents, but divide the coefficients. So what would that answer be? Just 2. And then when we take 12a squared and divide it by 4a, 12 divided by 4 gives us what? 3. And then subtract your exponents, we get an a. So do you see how this is what we're going to do down here. We're going to be given the answer that would come about if we distributed. We're going to figure out what the greatest common factor is and then what's left behind. All right, so let me erase. That was just an example, numbers I made up. So looking at our first one, 2a squared plus 8a. What would be the greatest common factor? 2. What about variables? A. So if we take 2a squared and divide it by 2a, what are we left with? Just an a, 1a. Because 2, any number over itself, like our 2 over 2, that's going to be 1. And then we subtract. And then 8a divided by 2a gives us what? Just 4, because our a's cancel out. And then the way to check it is, in your mind, distribute your 2a. And see if you get 2a squared plus 8a. All right? So what would be the greatest common factor for number 6? Okay, 2 what? 2x. And then what would be our left behind? What else?
Could it just be 3? Plus 3?
X plus 3. Well, it was plus 4 in the first one.
What do you have to like work it out every time, or could?
Well, you can do it in your head.
Yeah.
I mean, you have to work it out. You can't just pick a number. But
Yeah.
sure, you can just work it out,
Okay.
in your head. Because like we're not writing down 2 and 6 and doing the factor trees.
Yeah, that's what I was
But
thinking. Obviously, you have to like work it out.
so 12 and 16. What would be the greatest common factor there?
4.
What about a variable?
A.
A. So what are we left with?
3A and 4.
3a plus 4. Good. Alrighty. Now we're back with 3 terms. So what would be the full greatest common factor?
3.
Nope.
3CD.
3CD. Is there anybody that's not sure how we got 3CD? I'll gladly work it if we need to. Any of these, because I want y'all got to walk away comfortable with everything we do today. All right? So does that make sense how we got 3CD?
Yeah.
Okay, what's our left behind?
6D.
6D?
CD.
No, 6D. Because your C's would cancel out. What would be the middle?
4C.
Plus 4C. And what's our last?
3.
3.
Wait, this is easy.
It's not a hard lesson, but there's just parts of it that you've got to understand to make the next part work.
And that's it. That's the answer.
Oh, yeah, we're done. Oh, I'm glad you asked that, Mamie. Yay, you. Because, guys, look at this. We're going to back up to number 7 for just a hot second. You told me the greatest common factor is 4A, right? I'm just going to say you're working your homework and you look at that problem and you say, oh, the greatest common factor is 2A. All right? Let's look at what happens if you were to grab 2A as your greatest common factor. You would divide this by 2A and you would end up with 6A. And then you would divide 16A by 2A and you would end up with 8. Look at your left behind. 6A plus 8, they still share factors. They're both even. And 2 goes into all even numbers. There's a hint if you haven't gotten all of the factors out. Okay? So that would be, wait a minute, I didn't get the large. You may have gotten a factor, but not the greatest one. So that would be a hint that you need to continue.
So if they share any multiples, then it'll be incorrect.
If they share any factors.
Share any factors.
Yes. That means you haven't pulled out all that they
Their
share.
factor would all be 2 here.
Wait, do what now?
Their factor would all be 2.
This would be, they share 2. And then you could say 2 times 2A, and that would get you to 4A.
Okay.
All right. Look at, the back of this. Number 9, super easy. So tackle number 10.
Wait, do we do number 9 now?
You don't have to, but I want you to work number 10. All by your lonesome. So what did you get as the greatest common factor?
5xy.
Nope.
5x squared y.
Wait, say that one more time, Wesley.
5x squared y squared.
5x squared y squared. Notice this. In this case, your two options, you have an x squared and an x cubed, and a y squared and a y cubed. The greatest common factor for variables will be the smaller exponent. So like x squared is smaller than x cubed. X squared means they have two of them, but x cubed means there's three. So they would share two, but not the third one. So go with the smaller, same exponent, same base, but go with the smaller exponent. That's kind of the shortcut. And then what would your final left behind be?
1 minus 4xy.
Oh, I heard it. 1 minus 4xy. Now, guys, this first term is the exact greatest common factor term. So any number over itself is always 1, not just thrown out as a 0. Okay? So what would the answer to number 9 be?
2x 1 plus 3x.
2x, actually the other way. 3x plus 1. 2x, and you need to be sure to have it in the order that they came. So you would have the 3x first and then plus 1. All right, are y'all good with greatest common factor?
Yes.
And then our parenthesis, I kind of call it just the left behind. It's what didn't get selected. So our next part is called grouping. Notice how many terms do we have? 4. These are like bigger polynomials. If we had just binomials or trinomials, it would be one way. We could look at all the terms. But for this, we have 4. And they don't share anything because they would all 4 have to share. While 4, 8, and 6 share a factor of 2, and 3 and 6 share a factor of 3, they don't all 4 share something. So you would just be stuck if you tried to do it that way. So the way we do it is break it into 2 binomials. So I'm going to split it before the second operation sign. And we're going to work the first binomial all by itself. And then we're going to work the second binomial all by itself. And then we're going to talk. Okay? So what would be our greatest common factor for the first binomial?
4.
4b.
4b. Don't forget your variables. All right, then what's left behind?
1a. 4a.
1a plus
1. 2.
plus 2. Anybody have a question about how we came up with that? Okay, here's the deal. Your second set of binomials, when we go to factor it, we need to have our left behind, which is the part in the parenthesis, they need to be identical. And if they're not, either you have factored incorrectly or we may have to manipulate some of the numbers. So let's go see what happens. 3a plus 6, what do they share?
3.
So positive 3. And then what's left behind?
A plus 2.
A plus 2. All right, did we get an A plus 2?
Yes.
Yes. So luckily that was great. Now we're done with the work. We just need to finish it by putting it together. You take the greatest common factors, which in this case are 4b and a positive 3, and you create a binomial of those inside a parenthesis. So you would have 4b plus 3. And then you take the left behind, that identical, and you write it one time as a binomial, a plus 2. So you have 2 binomials. How do we check binomials? We FOIL, okay? So I'm not going to write it, but I'm going to state it. So first, 4b times a is 4ab. And that's what we wanted. Our outer will be 8b, and that's what we got. Our inner is 3a, and our last is 6. So you see how they end up. You can still check yourself. You'll end up with 4, in this case, 4 of your clumpies. But this would be your final answer. Now, on tests and quizzes and quests and whatnot, if you give me just this, your work, so to speak, I will not give you full credit. You must take the greatest common factors and make a binomial, and then list the left behind one time, the identicals, as the other binomial. This is what I have to have as the final answer. Okay? So even if it's right, I will ding you just a little bitty bit. But I've got to have it written as a binomial. As your two binomials together. All right. 12, where we have 35x. Where do we split this one?
In the plus and then
Yep, before the plus for the 3x. So what would be our greatest common factor for the first part? 5x. And our left behind?
7 minus y.
7 minus y. Everybody good with how we got that? Everybody agree? Okay. What is the greatest common factor for the second half? 3. And we're left with y minus 7. And that was a positive 3. Okay. Let's look at our left behinds. Are they identical? No. They're actually the same letter, the same variable and number, but the signs are opposite. What could we do to make the signs be the same? We're going to multiply this, because in your first binomial is the driver. You're not going to mess with it. What you'll tweak every time would be the second set. So you take everything past that blue line, all of this, and we're going to multiply it by -1. In other words, instead of our greatest common factor being 3, we're going to make it -3. And that's going to change what's left behind. So if we say -3, what does the y become? Negative y. And what does the 7 become? +7. And while they're not in the same order, the two parentheses, they are the same signs. +7, -y. +7, -y. All right, so when we go, what will be our first parenthesis then?
5x. Right.
5x.
Oh yeah, 5x minus 3.
Minus 3. Good. And then for this problem, you could pick either way. Personally, this is just me. I like the first number to be positive. You could pick the -7, -y plus 7. I'm just going to go with 7 minus y. It'll get you there. It'll get you to the same answer. All right. 13. Where do we split it? Right there. Okay, I'm going to erase this part. So what would the first factoring give us?
3. No, 14. 2.
2p. What's left behind? 3y plus 8. All right, everybody good with that? Because I got a question. I want to show you something. We have said that the first binomial is the driving. So that left behind, we need the second left behind, the second parenthesis, to match this. What kind of sign does the 8 carry here?
A plus.
A positive. We need to work it so that the second left behind has a positive 8 at the end. Okay? And what can we do with a negative so that we have a positive?
Make it a negative.
All right, so the greatest common factor will be -5. And that's going to give us what as a left behind? 3y plus 8. So what's our final answer?
2p minus 5, and then the other parentheses, like 3y plus 8.
Yep. Excellent. Yes, ma'am.
3c.
Sorry. Thank you.
I'm just a little bit confused on the very end. Like
On what?
when we made it from the 2p, how you got 2p minus 5.
Oh, you take the greatest common factors, which are the numbers that you put outside
Okay.
what you removed, and they join together to make a binomial.
And then the inside of the parentheses have to be the same.
They have to match,
Okay.
and it needs to follow the first one. Because probably, if you looked at this, I think it's -15y minus 40, you'd probably say 5 is your greatest common factor. But then when you work it, you end up with -3y minus 8. So you need it to be positive, so you have to change the
Yeah.
positive 5 to a negative.
Now I get it. Thank you.
All right, yes, ma'am.
Well, wasn't the 5,
Okay, we're not chit-chatting like this.
wasn't the 5 going to be negative either way because it was a negative in front of it?
We could have removed a positive,
Oh.
but you would have had to go back and change it. All right, what I want you to do at this bottom part is work I don't know why there's conversation. We've got way too much to do. Work, please, 1, 2, and 4.
Is this what we did in the beginning?
What should you always ask yourself?
What is the common factor?
The first thing you always ask is, what is there a greatest common factor? Sometimes there won't be, but there can be, yes.
Is it 5?
Sort of.
Let's try.
Sort of.
Uh-huh.
Sort of. What name you
Oh,
use?
it's 5A.
5A.
5A, excellent.
5AB.
No B, because the last two do not have a B. They all have to share it. Why didn't you tell me A squared, Lane?
Ma'am?
Why is it not A squared?
Because 10A doesn't have a square.
Very good. You go with the smaller exponent. Very good. So, Lane, what would the inside be?
Oh, you got this?
You got this.
I don't know how.
Please don't talk like that.
You said the S word. 3?
Uh-huh.
Well, actually,
Well, 15 divided by 5.
oh, 3. You working? B?
All right, A squared over A gives us A squared over
3A.
3A. And then that little thing you're right with the B.
Oh, it's 3A.
3AB, because we don't have a B to remove with the greatest common factor. What would be the middle?
A.
A. And what would the last be?
2.
Positive or negative?
Negative.
Negative.
Ain't that
Excellente. All right. Work number 2, guys.
Oh, I already got it.
Ah, what do you got, Mamie?
I might be wrong. I got 4M plus 3 in one of the answers.
4M plus 3P's. Looking good.
And the other one is Y minus.
I got that too.
Why what?
Y minus 5.
Yes.
Yay.
Perfect. Everybody good with her answer?
But you need to put both answers, right?
Well, you list the left behind only once. But yes, you would have to put
work it out. Yes.
yes, and then that you take your greatest common factors and put them in one parenthesis, and the identical
But
left
that's
behind in the
The
other
answer is the.
is that. Yes, ma'am.
Okay, I kind of got the answer for number 4, but I'm just confused with the signs.
I don't know why there's conversation. I'm about to do referrals. I mean, it's because you're not doing what I'm asking, and it's real distracting to others. All right, so what?
Okay, so I did the first one and I got x squared and then
Good.
x minus 4 in the parentheses.
All right, nothing wrong with that.
And then for the other one, I got negative 9 and then parentheses. Would it be x plus, or would it be plus?
You tell me. Watch the
Well,
signs.
That one's negative.
Do the math.
That one's negative.
You removed a negative number. What is a positive divided by a negative?
A negative?
Yeah.
Huh.
Uh-huh.
Oh, I got it.
So, what would your final answer be?
It would be x squared minus 9, and then x minus 4.
That is perfect. Okay.
Wait,
What, Wesley?
would it not become plus 9?
No. Once you work the first one, you see that we need a negative 4 to be our last part of the left behind, and we have a positive 36. How can we work with it to make it a negative answer? That would be to take the positive 36 and divide by a negative. Because if you divided it by a positive, you would end up with still a positive. Yes.
This is actually really cool. How it works.
It's like not hard.
I love,
So cool.
yeah, this is why I like math.
I love
All right.
this now.
We are moving to the latter part of the lesson, but we're still using everything. This page we're coming back to. I'm hoping to come back to number 4 before we finish. All right. And you'll see why in a hot second.
Do we not just do number 4?
We're coming back to it for just a revisit. And you'll see why. All right. We are going to the back page. You should have this already as your third page. Difference of perfect squares. We've had this lesson. We put our toe in the water not long ago, just probably a couple of weeks ago, and we talked about difference when we did special products, and we had difference of perfect squares. I need for you to come move right up here.
Yes.
Thank you. And we worked with perfect square trinomials. I don't know if y'all remember that, but we touched a lesson on that. So we're looking at difference of perfect squares. What does difference mean? Subtraction. What is a perfect square?
Square root. Like what?
It can be divided
49,
by
like 2 times 2 equals 4.
All right, so what is 35 a perfect square?
It can be divided.
Is 36 a perfect? What?
6.
6.
Oh, 6.
What about 64?
Yeah.
What is it? 8. What about 50?
Yeah.
No.
What about 49?
Yes.
7. Okay, so y'all are with me. So it is a perfect square if the factors are the same number used twice. Variables. Let's talk about exponents for a second. All even numbered exponents are perfect squares. Because when we are multiplying variables, we add exponents. So you will just cut the exponent in half. So if it's x to the 14th, what would the square root of that be? X to the 7th. X squared would be x. Okay? All right, so difference means subtraction, and it only works with a binomial. Only works with a binomial. And the two parts that make up the binomial, the two terms, need to be perfect squares. So subtraction along with two perfect squares. And then we factor them. All right? So what makes up x squared?
X.
What makes up 4? 2. So when we're going to write them, we're creating the binomials that if you FOIL, you would get back to x squared minus 4. And they have to be opposite signs. Because how can we multiply and get a negative number?
Opposite sides.
Opposite signs. So your binomials have to be opposite signs. So when you do first for this, you get x squared. Your outer is a negative 2x, while your inner is a positive 2x, which means they cancel each other out. And your last gives you the negative 4. So if you said, oh wow, we have two numbers and they are perfect squares, but it's addition, and we work it that same way. Now, how do we get a positive number? The signs have to be the same. So we would have x plus 4. I'm sorry, my bad. I didn't break it down. X plus 2. X plus 2. And when we go to check our work, our first is x squared, but our outer and inner would give us 4x. We would have a middle number. And then we would have the plus 4. But we would have a middle number in here that we don't have for the original. All right, so that's why we can't use it when it's addition. Only when it's subtraction. So you work the second one. No, that was an example of why you can't use addition.
Does the x always have to be first or does it matter?
You do it in the order that it's given in the problem. You work it left to right in that order. Do what?
I feel sick.
Really?
Yes.
Yeah. You feel sick?
Yes.
So what would you get? Parker? So what do you get for this one? What?
You get you get 2x minus 5y,
Mm-hmm.
and then you get 2x plus 5y.
Plus 5y. Now, notice mine was plus minus in the first, while Mamie did minus plus in hers. Either way doesn't matter. Because commutative property allows you to swip them around in multiplication. All right, are we good with how she got that? She took each component by itself and did the square root. Excellent job. What about number 3, Baxter?
A plus 8 and A minus 8.
A plus 8. A minus 8. Excellent. Sophie, number 4. What would we get?
M plus would be 4 over 5,
Yes, it would. Take the square root of both. Excellent job.
and then M minus 4.
M minus 4 over 5. Great job. Now, number 5. What do you do?
1x minus 4. 2. 1x.
Okay. What were you told to ask yourself
X plus 4.
every time?
Greatest common factor.
Greatest common factor. What is the greatest common factor?
2.
2. Then what are we left with?
X squared.
X squared minus 4. Now, let me say this. 2 is not a perfect square. 8 is not a perfect square. X squared is. But when you remove the greatest common factor, then what's left behind ended up being the difference of perfect squares. Lila, if you'll come move right over here. So then you break down x squared minus 4, but never, ever, ever leave the greatest common factor behind. Okay, make it travel. So we would have x plus 2 x minus 2. And the reason being, if you were to leave that 2, I know it's like that one was an easy one. You could probably just do it in your head, obviously. But if you didn't write it down with your answer and you FOILed, you would get x squared minus 4 as your answer. As you're checking your work, and it needs to be 2x squared minus 8. Yes, ma'am?
So how do you know when to leave like the 2 in front of it?
It's always, that's what I'm saying. Every time you have a greatest common factor, it just travels along like a piggyback ride.
Oh, so if the greatest common factor is already in it, it stays with it?
If you remove it from its original binomial, it's still part of what we're doing. We're not coming up with a new value. We're just restating what's given. The value remains the same. We're not solving for a variable yet. We're going to get there, but we're not solving for anything yet. We're just taking what we're given and finding a new way to write it, not changing its meaning. So that 2, if we throw it out, then we will only have x squared minus 4. We won't have 2x squared minus 8. And so the 2 you would, FOIL and come up with that. I'm not sorry, just not FOIL, distribute to get back to that. Yes, Mamie?
Why would there not be a 2 in front of the parentheses x minus?
Because they are like, if we knew the number, if we knew what x was, this would be a number and that would be a number. And 2 was removed only one time from it. And so move right over there.
So if it was 4?
I'm sorry, if what?
If it was 4x, it would be 2 in front of each.
Nope.
Oh.
You just remove the greatest common factor and it rides out in front of the first parenthesis every time.
Wait, what
It won't go in the middle.
What do you mean rides out?
Well, we wrote it outside. We wrote
Oh.
the greatest common factor outside like we did in the others. And the only reason we took, like that we had the binomials where we put the greatest common factors together was because we had 2 binomials that we were working with.
So why wouldn't you do that with number 2 then? Because the
Number-
change.
Wait, with where?
Number 2.
We didn't have a greatest common factor.
Oh yeah.
That 2 is part of the square root of 4.
Okay.
All right, number 6. Is m to the 4th a perfect square?
Yeah.
Yes. Is 1 a perfect square?
No.
What's 1 times
Yes.
1 times 1 is 1. It's neither prime nor composite, but it is a perfect square. So, y'all got to pay attention to this one. M to the 4th. What is its square root? M squared. And then how do we go from there?
0.5
No,
Plus
plus 1.
plus 1.
And then m squared
Minus
minus
1.
1. Okay. Does anybody see anything interesting and entertaining about the second binomial?
It's perfect square.
It's a perfect square again. So you have to keep breaking it down. M squared plus 1, we've already seen that even if they're perfect squares, if it's addition, you don't change it. But you also don't leave it behind. So it's going to be part of your answer. So how do we break down m squared minus 1?
You break down m squared.
To M.
So we'll have m squared plus 1.
Just do that. What? What's that do? What? Yeah.
How did the marker fly?
Which direction did it come from?
Okay, we'll talk over here after class. M plus 1. And then m minus 1. All right, so do you see how and why we had to keep going? We had the difference of perfect squares, and we had to keep writing it out.
Why didn't we do M squared for the first one, but M and N for the other 2?
Well, m squared plus 1 doesn't change.
Oh, because you
So
only
it's addition.
do this different. You only do the
You only break it down further when it's subtraction.
Oh, because they're perfect squares and you can't do for the square
Yes. All right, you do number 7.
Dr. Green, can you tell us the square of 162?
Nope. Because what are you supposed to ask yourself every time? How do you begin each problem?
Wait.
You're looking for the
greatest
greatest common factor. Do they share anything?
Yes.
They're both even, so they share a
2.
2. And you should be able to do 162 divided by 2 without using a calculator. Take it apart. Work with the numbers that you're given. The first part divided by 2 and the last part divided by 2. And what would it be?
81.
81.
81.
16 divided by 2 is 8. 2 divided by 2 is 1. Good.
81.
So we're going to be left with, first, the greatest common factor. And then we have x to the 4th minus 81. And the question you ask yourself after you've said, is there a greatest common factor? Your second question is always, is it the difference of perfect squares?
You're not done yet.
You're not done yet.
You thought it was over.
Yes, just began. So how would we break down this part?
X squared.
X squared.
Minus,
Doesn't divide.
can you put it in points? Like 40.5?
No.
9.
Why? Why 9?
Squares.
Square. We're taking the square root, not dividing by 2. Square root. So we have x squared minus 9, and we have
X squared plus 9.
Minus.
x squared plus 9. Then we go back and we think we're through.
No, you thought it was over.
But you ask yourself, is this a difference of perfect squares?
No. Yeah.
Yes. Is the x squared plus 9 the difference of perfect squares?
Now it's x minus 3.
But is the x squared plus 9 the difference of perfect squares?
No.
It's addition, it's not difference. So it stays.
The last one has to be the subtraction.
So what do we have as our final answer?
2 plus 3.
What else?
And then
X minus 3.
Oh my gosh, you did.
What else?
And then it again.
X
And then x
plus 2, or X.
minus 3.
We've done x plus 3, x minus 3. That takes care of the x.
X to the
X
third.
minus X squared minus plus.
Wait, why would it be to the divide? Multiply.
X squared plus 3.
Just X squared. Oh my god.
What?
Just
Okay.
All right, as we're working it, you broke x to the 4th minus 81 down as x squared minus 9x squared plus 9. And then that would be, hopefully you're through, but you ask, is it a difference of perfect squares? The first one is, but the second one is not. X squared plus 9 is not. So, but it's still part of the answer, so it travels along like your greatest common factor does. So you rewrite the difference of perfect squares as x plus 3, x minus 3. And then you have the original parts that you removed and the part that was not a difference of perfect squares.
Why did we keep that one?
Because you need to be able to check your work and get back to 2x to the 4th minus 162.
Okay.
If you throw any pieces or parts of this out, you won't get there. You'll be lacking. Yes.
When I worked it out,
Shh.
I got 2 x squared plus 9 and then x plus 3 x minus 3.
Mhm.
Does the order matter?
No, because they're all factors.
Yeah.
That's what I would have put anyway, is the square before the other.
Okay.
So I like your order better. But these are all 4 factors, all being multiplied. So the order, you could technically put the 2 at the end, but don't. Put it before the parenthesis. All right? Is there a problem?
No, babe.
Well, then put your arms down.
Oh, sorry.
Thank you.
I was reading a clock.
I'm aware, but it's also distracting all around you.
Can I be with my fingers?
Well, Tully is having too much fun.
No,
Now-
she wasn't laughing at me.
Oh, well, someone is. So, do you have questions about this? Okay. You have homework from the textbook.
This is kind of confusing.
Is the reason you don't keep n squared for the first one?
Wait, which one?
Number 6. Is the reason you keep n squared for the first one because one can't go in, like they don't have a red solid back?
No, because right here,
Yes.
No.
No, for the final answer.
right, m squared plus 1 is not the difference of perfect squares, and they don't share any factors.
So
So,
the reason we took it off for number 7 for the first one, like it isn't x squared because it did share a common factor.
we had the 2 as the common.
2 was on the outside.
Yep.